It says virtual background, appearance, video, not seeing my video, integrated camera, original ratio. Okay. It says mirror my video preview, but I have off it. No, it should come, right?
Sir, are you using a webcam?
No, it should come,
External
right?
webcam?
No, laptop.
Sir, are you using a webcam?
No webcam. It's integrated camera. Integrated. Maybe let me go out once. Maybe it may do something better. Let me
Yes,
just go out.
maybe we can try that. YouTube Live is working fine.
Hello, make any updates on the live Zoom?
Live is working fine, Priyansh.
Okay. Thank you so much.
Prof. Sir, when you go to video settings, on the right upper corner, you will see the rotate button. You're on mute, sir.
So video setting on the left bottom, right?
On where you're seeing the video, there's a option to rotate. Just maybe click twice.
Rotate.
On the top right corner of the video which you're seeing, you will see a square box, just like a photo rotate option is there. That kind of thing is there.
Time. Generally, it does not happen like this. I don't know why it is.
Let me just show you.
Please.
So if you go to video and you go to
what is it? Are you showing it
on the screen? Can you see my screen?
I can see a screen.
So here, if you see,
but
this corner.
Okay, my Zoom screen doesn't show like that thing. This is your Zoom screen?
Yeah, so when you video setting, there will be an option of rotate. At least in mine, it's coming. Like it will say rotate 90 degrees.
Let me just mute, blur my video effect. Mirror. Very strange. Side up view. Anything changes happen or no?
No.
Swap video and share screen, full screen, swap video. Where am I? I'm not able to see myself. Okay, let me try. Actually, I'm connecting through browser, so maybe that happens. So maybe try to do through app actually. Let me just try to do.
Yes. You go directly to Zoom. Yes.
Okay.
So one more thing, I don't know how I am not able to access the live chat on YouTube. I can't see it.
None of you are able to see, only Rhythm is not able to see. Now check, Rhythm.
Checking, sir. Refreshing. Mm, no, sir.
You should be able to see in the bottom chat.
Just a minute.
Maybe there's a more option. You can go there.
Yeah. Mm,
Uh,
yes, sir. I'm able to see it now.
Good. It works now.
Perfect. Right on
Okay.
time.
Yeah. So just if I can just do the blur my background. Okay. So I just check my presentation once before you formally.
Yes, sir. Yes.
So yeah. So.
Just a second. I'll just
Mm.
make you co-host.
Mm. Enter screen. Enter screen. Mm.
Yes, it's visible, sir. Yes, it's moving well. We can see videos also. So you're on mute.
Yeah, so someone has muted me actually. Anyway,
Oh,
so
okay.
just check if my video sound is audible or
Yeah,
not.
sound was there, sir.
There, right? Sound was there?
No, can you play again? Because earlier sound was there. This time I could not hear. No, I can't hear anything.
Not there, sound?
No, no.
Okay, again I have to go to the setting. There is some setting of sound. Okay. Whistle stop incoming. Where is the setting? Mirror. Default headphone. My audio option. Computer audio. I'm a little scared to go out again because my photo came right, my video came right at this stage. And audio, okay, I got an audio. It says there has to be computer sound to be shared.
Yes.
This speaker. Anyway, if it doesn't work, I don't mind much actually.
So I think, sir, you stopped sharing. Once again you share, there's an option comes on the bottom that share audio also.
Stop share.
Stop
Okay,
sharing and
right.
share again. Share again.
You're right. You're right. Yes. I think someone is disabling me actually. You have to give me entire screen, no? Okay. Okay, now it's done.
Perfect, sir. It's there.
Actually, someone has to check. Please don't unmute me, otherwise we will not have a dialogue at all. So I have unshared. I've unshared, so it's all yours now. Let me know when to start. Anurag, you're on mute.
So without any further delay, I think let's start the session for today. Meg, you have something to say before I start? All right. So I welcome everyone for this next edition of April month of MIC webinar series on theme of AI in medicine. And today we are honored to have a very senior and a very distinguished faculty with us who will be talking about the role of robotics. As for last at least 20, 30 years, robotics have been a very important integral part of all the advances and innovations which are happening across various sectors. He'll be talking about that, and also he'll be trying to touch upon what is the future and where AI will integrate with robotics. And so about Professor Subir Shah, he's a distinguished academician and very globally respected mechanical engineer and faculty from IIT Delhi. He's also the project director at IHFC, which is iHub for Cobotics, which he fondly says it's a collaborative robotics is Cobotics. So he wants and he is working tirelessly for last several years, bringing people together, working on robotics in various fields like healthcare, defense, agriculture, climate, weather monitoring, many areas, and he'll be talking about it in his talk. So, sir, we are honored to have you, and IHFC and sir has been a very steady partners with MIC as well, and we were discussing about setting up this center for many years, and now it has actually seen the light, and so it's all because of his advices and guidance. So, sir, without further ado, I'll invite you to give your presentation, and then we have a discussion. Over to you.
Thank you. I believe I have about 60 minutes, 50 minutes to talk,
Yes.
and then, okay. So maybe 45, 50 minutes. So thank you, Anurag, for inviting me for this prestigious online talk, and I'm happy to be here. And IHFC is happy to collaborate with the prestigious institute like MAMC, and we would be glad to interact or more collaboration with MIC. Before I start, a certain anecdote. Now, Meg has been in touch with me for several days, and I had some observations and some thoughts I shared in the afternoon. As we go along, maybe I'll share. And at the end, I have some suggestions for the team, MIC seminar series team, particularly Anurag, who is leading, to consider for better engagement of the participants who come here. So with this, I'll share my screen and let me just share the screen and audio screen. Hello, screen was visible. Am I right?
Screen was visible, but as soon as you share, I think you go on mute. I don't know why.
I didn't mute it, and I think the Zoom is very smart, possibly doing something. So maybe Meg or someone can keep a tab that I am
Yeah,
not
yeah.
going to mute because I may keep on talking and then things will be missed out. Okay, yeah. So the title of my talk I have given as a twist with medical robotics. As I said at the beginning, and Anurag has also mentioned, I'm not the medical robotics expert, but I've been working robotics for about 30 years. And some people dragged me in the medical domain, even though I didn't want to. I'll share those experiences. Anurag is kind of one of them. So that's IIT, one of our convocation hall. Architecture is very beautiful. And the top right is our research innovation park where our IHFC is located. I have foundation for Cobotics. So today's outline, the participants, I have been told by Meg that, okay, you wanted to put forward learning objectives online to see whether people would attend or not attend. For them particularly, you may decide to leave just after this slide, or you can stay back. So the left-hand side, what the flow will go on, my interest as a faculty, as a researcher, and then what we have done as a part of mechatronics laboratory and program for autonomous robotics laboratory, which has given impetus of robotics activities at IIT Delhi and of course the IHFC, the way it has come from Government of India. I have been successful to license one software called RoboAnalyzer software. It is a basic software to understand robot movements for that matter. And then that IHFC, I have foundation started in 2020. And here I will share some of the projects in the area of medical or healthcare systems, how various faculty and doctors are working in this domain, which might be interest to some of you as a future collaborators in the form of grant projects. So we have combined several projects. We do have certain facilities, one of them in your interest area, the medical interest, the Medical Cobotics Center. We have housed one human patient simulator, it's a high fidelity simulators in Okhla along with IIIT Delhi. It's a collaborative activity. Then finally, I've been dragged to AI by one of my students in 2020. He says, I wanted to do AI in robotics, and he has succeeded to develop one autonomous ultrasound robot, basically, which I will share towards the end and the conclusions. And as a part of this discussion, so learning objectives, what we'll take back with you is you get to know what are the robot applications in general, and particularly robots in India. We, as an Indian, unfortunately, we are generally not very proud of what we have, but what other countries have it. So for them, no, I wanted to explain how robotic companies are doing in India, doing good, and basics of robot analysis. For those, of course, medical doctors may not be very interested, but when they collaborate with scientists and engineers in the domain, so they need to know some basic fundamentals. Doctors knowing it would be advantageous. Then the research opportunities, as I mentioned, the left-hand side grant project and startups particularly, because whole country is now talking about startups. So we have a lot of fund invested in startups. One of them, of course, surgical robot is doing very good business. Not business, is growing up actually. He got external funding from many sources. Articulus, I will tell you towards the middle. Then research in neurological robot. One aims neurosurgeon was Ashish Shuri has kind of the first doctor to drag me in medical robotics, and he has been kind enough to tell me, I will teach you medical, no, you teach me the robotics kind of thing. And then the tele-ultrasound, it has been news not only in India, we're the first country in the world to demonstrate a tele-ultrasound robot with another doctor, Dr. Chandrasekhar from AIIMS New Delhi. And then concept of AI, as I mentioned, Deepak Raina, the boy, he is faculty at IIT Mandi now. He has spent 2 years in Purdue University with Professor Richard Wells. There they have demonstrated that how, based on AI, they have complete autonomous, which is far away at this moment as a product. So that's me. So I have two major interests. One is related to the education, because to me, present day education system is quite boring actually. So we need to have innovative teaching methodology. And one thing which I found out over last 20 years roughly is the robotic competition based education and engineering and innovative teaching. Like for example, if you see this robot which has been licensed to a company in Pune, the journey started in 2008 when our students have taken part in a competition called Robocon, robotic contest. Even this year, we will organize at IIT Delhi from July 2nd to 5th, based on the theme created by the international community, and the winning team goes to the country. This year, it will be in Hong Kong. So, the basics of such things are documented in my textbook called Introduction to Robotics. This is the third edition. Then I mentioned about this robot analyzer software, which I'll spend maybe 1 minute later. So this is the innovative teaching. Whatever we teach, whatever you would learn, and you can experience using this robot while you build it. For medical domain, I've been fortunate to participate in a conference in Vaidehi in Bangalore, and I met an American professor who originally Japanese, and Sim Wars. It's a very nice competition he does with the medical students were using high fidelity simulator like HPS I just mentioned. You create scenarios, and then the students in a group of 5 or 10 doctors come and do some actions in about 10 minutes time or 15 minutes time to take care of the emergencies, the traumas, and the experts are watching, and then they are decided winners. So very similar to the rugby concept, Seamworks, and I've been talking to professors like Anurag and others, if similar thing can be done in India, and it will be real fun. The second one, I have a lot of interest to the social sector. For example, here you can see a machine which is cleaning carpets. For those who are from UP, they may know a place called Vadohi. It's a district town, a small district town, and this is called carpet capital of India. And people who cleans or who weaves, they go through a lot of drudgery. So we as an engineers wanted to help them by creating machines. But once the machines are developed, they need to be optimized. So as a part of research, I give this concept called Mudra, multivariate dynamics for rural application. Now, multivariate dynamics is a research area where anything moves, you can predict its behavior. Like for example, left-hand side, the robot's behavior I can predict without really making one. That's multidynamic. And this is innovative research, because this kind of research America doesn't need it, or Europe doesn't need it, because their problems are very different type. So for me, why do I copy their problems and solve it? I can solve my own problem. And the next one is very interesting. Very here for Mathura, there is a place called Jade. They make beads from the tulsi stems to create tulsi mala for the ISKCON temples mainly. And over a period of 10 years, we have changed their life. And if you are interested to know more, you should go to this media coverage by Sansad TV called Innovative Bharat. And the title of the program is Mala Se Mala Mal. So I can prove you through Google search that if you give a search on carpet modeling, you will see our paper will come first. But if you go with the robot modeling, where also my area, my paper goes in the 40th page or 30th page kind of thing. So that gives you the idea that, okay, these kind of areas are innovative. To me, it's very refreshing. Coming to general robots as such, the robots are popularly started working in 1980s and later on, mostly in the factories, top left. Then warehouse, Flipkart, Amazon, when you give orders, so these kind of robots at the bottom, they carry, these kind of racks, and they're barcoded and sent by post. However, applications are expanding. This is the flying, the drones, and then these are the walking robots. They work along with the human in the factories. These are quadruped, again another type of walking robot. They carry loads for the army jawans, to carry and support. This is in water, autonomous water for patrolling and other purposes. The Google Maps are done by this kind of vehicle. They have cameras, and these days, and there are Tesla cars, autonomous. These are for the defense applications or emergency application. These are called bomb disposal robot, and again underwater for exploration of various minerals and stuff like that thing. This I have already mentioned. Now coming to what we are doing, that's in general. So here in one example, in our mechatronics lab way back 2001, we have developed what is called the driving simulator for the truck drivers. So this kind of device at the bottom is called parallel robot or the steer platform. Sorry. And the doctors would, not doctor, the drivers will be sitting here, and they will be practicing different terrain, maybe Ladakh or something like that. So this portion was our contribution as an engineer, or the researchers, you can say. And later on, we transferred the technology to Indian Army unit in Secunderabad. They have a simulator development division to do this kind of activity. However, coming to medical application, one of my colleagues in our Center for Biomedical Engineering, he came to me once to help. This is an insert. I mean, you put it inside the bodies, and this needs to be aged. So it goes implants. So this is one of the implant, and it has to be aged quite accurately at regular interval. So he came to me. If you do it manually, then obviously it may not happen in regular interval. So the same concept in a scale down, it has been done to do this thing more systematically. So big one and the small one. But this guy has an application also. You doctors, when you do some kind of surgery, now to reduce the vibration of your hand, you can put your hand on the top of it and let the robot guide you. And once you come to the appropriate place, then you can put your cutting tools to cut vein or whatever you like to. So it has a stabilizing effect. Then comes to another kind of robot which we have done it for Bhabha Atomic Research Center way back in 2010, and where we wanted to do some assembling operation, putting some cylindrical objects inside another one. But before that, my student is trying to see to make it compliant. So the purpose of the compliance I'll tell you a little later. And this is one of the example called the teleoperation. So many of the surgical things are done remotely over long distances. So this is one such attempt. So we did it. And finally, this peg in hole operation, where you can see that this cylindrical object needs to be inserted in a hole. But if you use only camera system to see go inside, it will not go. It's like in the darkness, if you have a key of your room, no, when you see it in the daytime also, no, it will not go straight inside the keyhole. So you go next to the keyhole and just to play a little bit here and there till it gets inside. So you are actually taking help of the force also along with your vision. So that's called adaptive force control here for this kind of operation. Finally, the teleoperation. Later on, I will show you a live demonstration of this thing. So here what we do is, this is called haptics device, which gives the force feedback. Whatever robot is touching here in the real environment, you will get a feel for it. So this is almost like a mini robot. It has also 6 motions. Typically, our hand has 6 to 7 motions. And in all industrial robots, they are all what we call 6 degrees of freedom, means it has a 6 motions. And if it touches, it gets a feeling. So in I will show you at the end when the doctor was doing ultrasound. You need to understand how much force should apply to get a proper views of the organs inside your body. So in this case, it was just about few meters away. We could successfully do this teleoperation. But as I said, later on, I will show you 12,000 kilometers away. So these are the typical varieties of robots, if you wanted to understand. So these kind of things are used in warehouse automations, these 3 here. This is the space, ISRO. These are floor cleaning robots. This is again flying robots. And these are kind of industrial robots. And these are kind of defense robots, right? So India is doing quite well these days. May not have matured to the extent of, US, Japan, or some of the European countries. And recently, we had a meeting at Hyderabad to organize IEEE's International Conference on Robotic and Automation 2030, 5 years down the road, 4 years down the road. And the expert came from Hong Kong on behalf of IEEE. He said, I didn't know there's so much activity of robotics happening. Maybe world should hear about Indian robotics. So he said you have everything, humanoid robot to flying robot, all such things. So we are very hopeful 2030 we should be able to get that conference here. We are competing with Thailand basically. So other type of robots, again, like a parallel robot I have just showed you as a simulator. These are called the walking robots. These are kind of cobot. I'll give the definition of cobot later on. This goes underwater. And this, many of you already might be knowing it. Sudhir Srivastava, he created a company for surgical robot to compete with Da Vinci. He says he will give 1/5 of the cost of Da Vinci. And I've been told recently he has deployed about 200 around the world. This is another diagnostic robotic company in Chennai, Parfint. And this is the company where we did the tech transfer in Pune. These are actually educational robotics. This is called AMR, Autonomous Mobile Robot. This is a Ruben software. And this is a software from ISRO for finite element analysis for engineering structural design. So if we are studying robotics, or if you want to learn robotics, it's like ABCD of English. If you do not know ABCD, you don't go anywhere. You get stuck. So similarly in robotics, if you wanted to understand, then we must understand 4 basic things. There are many, many, many things otherwise. So kinematics, as we study in our class 11 and 12 science student, kinematics means relationship between the positions of these rotations here versus this kind of end effector, we call it, where you may put your surgical tool or welding gun for the industry people. Then you have a dynamics, that how much force needs to be applied here, or how much motor torque has to be applied here. That we study in dynamics. But anything you do it may not perform the way you like to. So then we need to control it. So then there's a control thing. And finally, what is called simulation. Without having the robot with me, can I predict its behavior before I go for purchase it actually? So you do the simulation of robots also. Just to give you a feeling that what is this robot knowledge software does it, because this book has lots of maths behind the understanding of this kinematics, dynamics, etc. But many times students face difficulty, particularly early students. So for them, we created this tool called Robot Analyzer. For example, this is like your upper arm and this is like your lower arm. And you would like to know, given the motion of this shoulder joint and the elbow joint, where this motion of your fist will go. So you press what is called F key, and then it will show you how it goes. No. So this is the way you can understand. So before you really make one or buy one, you can try it out actually various ways. No? So that's the way, and then you can get the plot and etc. If you want to see how much force is required, you can click this, and then you can see that how much force will be required. It says torque. So this is a torque profile will be required. No? So these kind of things we need to know while choosing one robot, even for your application. Now, when you tell this is my application, we as your engineering partner will be able to guide you by going through this kind of tools and understanding of what kind of robot you should be buying. Now I take you to the journey of that IHFC, which I just mentioned. It is a Government of India's initiative in 2020. So we have been asked to do this kind of activities. The R&D investment, we do invest. We have about 50 plus collaborators around the country, both engineers, doctors, startups, companies, in the range of 50 to 60 crores. Then we have startups, about 50 plus startups, again, similar range, 50 to 60 crores. Then educational training, so school level training, college, engineering college level training, nurses and doctors using simulators. We don't do it directly by ourselves. We do collaborate with your people and then with some companies. And international collaborations, we do have collaboration with NSF USA. We do have with Denmark and Japan, and Vietnam, and so on and so forth. So we have chosen these 4 areas, and medical is one of very strong application we'd like to contribute because more than 90%, maybe more than 95% equipment come from abroad. And even though making is difficult, but someone has to do some beginning. People are working. We would like to help them, and we'd like to give some kind of support through engineering knowledge, bringing you people with engineering community to co-develop things and such ideas to flourish. As I promised, I will tell you what is a cobot vis-a-vis robot. Now, as Anurag has already told, it is called collaborative robotics. Please watch what this boy is doing. So this boy is actually trying to teach this robot to follow a certain path. Okay. So typically, if it is a robot, you don't do this thing. You basically do the programming, writing a codes for it, and upload to its controller. So this is an example illustration of a robot. If you put a robot program to move it from A to B, and if this guy comes in, it does not care if someone is away or not. It is when asked to go from A to B, it will go by hitting you. You may fall down, it doesn't care. That is the reason this kind of factory robots are kept in a cage for safety of the human being. When it's a cobot, they have been given some kind of intelligence so that as soon as it touches the human being, and if it crosses certain force value, that it is feeling more force and not able to move, then it stops. And then when the man moves away, then it moves. So it's very handy, cobot, collaborative robot, when one human being can work with it. And that's why Arun is working in this cobot And whatever he taught, you see, it is just following it. So number one, you can avoid the risk of hurting someone. Number two, you don't need to be very educated one. Even for you, your skill set is no medical operation, surgical operation. So you don't need to learn what is the programming, robot programming language to use it. You just teach the robot what to do, whatever you want it to do, and robot will replicate this thing, So for the other end, even the skilled worker like welder, they don't have to have a proper education of learning the computer language. They can still teach the robot and do it. So this work, the kind of algorithms we have put forward in a book called Vision-Based Identification and Force Control of Industrial Robots. So I'll spend about 3-4 minutes to show what are the profiles we have it. Some of you may know it because we have been closely interacting with MAMC, particularly during the MIC inauguration also. But for others, please enjoy this video for 3-4 minutes.
In the fast-evolving world of technology, where human and robotic intervention defines the future, IHFC, iHub Foundation for Cobotics at IIT Delhi is pioneering a revolution. A revolution that has already begun, with IHFC having set up world-class center of excellences such as Drone Technology Park, Medical Cobotics Center, and co-innovation centers which are bringing real-world solutions to life.
The iHub Foundation for Cobotics at IIT Delhi is one of the 25 technology innovation hubs set up under National Mission on Interdisciplinary Cyber Physical Systems.
With verticals spanning agriculture, medical, defense, and Industry 5.0, IHFC is shaping the future of India in the deep tech ecosystem.
Today, we have almost 40 startups and 25 early stage entrepreneurs, some already successful and some very high promising.
IHFC nurtures young minds from school through their educational STEM training from school through college to their entrepreneurial journey.
So at the end of 5 years, I feel proud that IHFC has contributed not only to create world-class startup systems who made a world record, at the same time, we are on the verge of productionizing one technology which has emerged from the medical field, particularly the prosthetic arm.
We have been working with many state governments and central boards to take this concept to the young minds of the country, especially at the secondary school stage.
The mission is poised to focus collaborations between government, academia, and industry, thus bringing out a robust innovation ecosystem in the country.
Looking at Cobotics and how Cobotics can change people's lives. We have been enabling innovators, startups, ideas, research, which make a difference.
What we feel is that this generation will be the one driving Viksit Bharat in 2047. We have also set up 10 co-innovation centers, which have been set up in collaboration with some like-minded and forward-looking institutions to take the vision of IHFC forward.
As IHFC completes its 5 years, it's indeed satisfying to note the achievements made by the hub under technology development, skill development, entrepreneurship development, and international collaborations.
IHFC now celebrates 5 years of its existence. We have come a long way. We have now created an ecosystem where we can support innovators, faculty members, researchers to take their journey forward in terms of cobotics to make a difference in the Indian ecosystem.
I wish we could make one of the best systems in the world to take our country, in the forefront of technology creations, and at the same time, Atmanirbhar Bharat, not only for Bharat, but also for the world.
Okay, so that was our corporate video, which we celebrated in September last year. And just to understand the kind of R&D things we have it, so there is a series of activity. This prosthetic arm you have seen in the commercial video, but this I wanted to show especially because it is with one of your doctors, Dr. Maini, Professor Maini from
since last 17 years in the domain of manufacturing automation. And this innovation, what we have worked with IHFC, is more about addressing the need of an orthopedic surgeon. In terms of the quality of the session, the bones, fractured bones can be done. And at the same time, also develop an automated technology to pre-bend the plates so that we can save operative time of a surgeon in the operation theater and also save a life of a patient. And we had a long collaboration of more than 10 years working together with the Professor Mani in MAMC, it's a Maulana Azad Medical College. So initially the need comes from the Professor Mani only. He was working to find out a method by which we can reduce the pre-operative time. So he gives some data of bones, fractured bones of some patient who admitted at the MAMC. And initially we followed an approach to 3D print a bone.
Okay, so that was funded by us, and Professor Shunil Jha has also created a startup which is also incubated with us. We do have some medical grade prototyping facilities. So that's called M Prakati. It is ISO standards, trainings are imparted. And I've been told by Professor Dinesh Kalyan Sundaram that, okay, some of the implants have gone into the patient's body as a test cases, and now they are working with various certifications. So they have all sorts of things. Whoever the doctors need collaboration will be happy to facilitate that activity. Here is Professor Dhiman Malik is trying to do some kind of sensor for the gait analysis of the human motion. So what we did is, as I mentioned in the first slide, introduction slide, that we try to make teams, because in India we are very good on individual level, but when it comes to team, we are extremely poor. So whatever number of projects came to us, so we try to club them actually. And then, for example, healthcare, 3 projects. Human robot interaction, 2 projects. Then I'm just catching the medical related rehabilitation robotics, right? Nano robotics, right? 5 professors. So just to plate bending, I have already shown you the video. Prosthetic arm you have seen during the corporate video, and this is one, the Professor Dhiman Malik, the sensor, which can study the gait analysis, and footwear design. People are thinking to create new, improved design based on the sensor there. This is a cable-driven ankle foot orthosis. I think this is been done at IIT Gandhinagar, professor, who got funding from us. And our ecosystem, I have just mentioned R&D, entrepreneurship, upskilling, and international collaboration. I have showed you some samples of R&D. Now we can see our startups, and this is a surgical one, which I mentioned while talking at the beginning. So this is a young chap from IIT Kharagpur, and his both parents are medical professionals. So he decided to create this company, incubated with us, and now he got external funding to proceed. He claims that he has done he's in the animal trial stage at this moment. So as an offshoot of his real robot, he knows the business is a little far away with the real robot. So he's trying to create some simulator with the software and some training modules so that he can get some quick business without waiting for very long with FDA approval or CDSCO certification and stuff like that. Okay, so you can provide more information as and when the interest comes. TSAW has actually demonstrated a cornea delivery using the drone system. So they are also incubated with us. And now, obviously, it is one of things, but once you have to do repeatedly, we need to have lots of regulations. So we're trying to work it out through ICMR. If some of the rules can be approach to be changed as a drone ambulance concepts kind of things, and let's see where we head. Once through ICMR we can approach the defense ministry or something like that. Okay, and then this was in a Kolkata-based company. A pharmaceutical students started with spurious medicines based on AI, and so they're also doing fairly good, and they got some orders. So this is a very cute device. We got this guy to our medical cobotics center, and we requested him if he can have the incubation here itself, so that he can show to all the medical related activities in Delhi and around. These are other two startups. This is like a disaster management. I may not be so much interested, but I will just play 10 seconds video for you. So the idea is it goes inside the collapsed building maybe, and then it has a camera in the front, and you see the boy is operating, and based on where people get stuck, you can rescue from there. No. The next one is for general understanding, 3D printed. You see that this house has been made by 3D printed robots. So this is the robot motion here, and then this is the concrete comes, and this is Chennai-based company called Kelvin 6. This is Botlab Dynamics, who made the country proud. Briefly, I will show you. It is mainly for entertainment, but it has a lot of defense application as well. I stop here because they are flooded with YouTube videos. You just go Botlab Dynamics, you will see. The important part we wanted to mention here is actually we as an Indian should feel proud of what we are doing it, not that what we are not able to do it actually. Generally we do the other way around. Ye nahi hota hai, wo nahi hota karke na. So this video is taken from 2023 in front of Rashtrapati Bhavan with 3,500 drones, but later on 24 they have showcased 5,500 drones in Anand Ambani's pre-wedding. So this is one of our very pride project. You can say started in 2020 during the COVID time. So Kritika was doing PhD after doing her all these higher studies in medical sciences. So she was there in IIT Delhi, and she wanted to have ultrasound down without touching the body of the patient. And there is a time one PhD student, Deepak, has initiated. I requested him, can he start working on this project? And obviously, soon after, COVID has kind of gone, and the boy has left for the US, to do the continuation of the next phase of this thing. So this robot has become, it became kind of, without any parents, no caretaker. It took another 2 years to convince another PhD student, Udayan, and to start this activity. And this is the robot and the doctor here. Dr. Chandru is sitting here with his haptics device and controlling what I showed in my robotics laboratory, the robot control, the similar architecture. But many things need to be taken care. For example, a patient might feel a little scary. So for him, it has an emergency switch here. And doctor has an emergency switch here also. So because safety was a concern. And on 16th February, we have demonstrated to Ministry of Earth Sciences. I'll show you this video of 2-3 minutes, and I think we should feel proud being Indian. Not necessarily it is my project, I'm feeling proud. And now we are thinking how to take it forward in future. So please watch, and I'm sure you will enjoy Antarctica for those who may not have seen it yet.
Sir, can you increase the volume, please, of the video?
Yeah. So thank you for watching, and so would be happy to collaborate anyone who are interested, because once it spreads, there is a necessity of for the even doctors who are uh, uh, should be able to control this thing, because now Dr. Chandu is a long practices, he has done it. Coming to Ready program, it's an interesting program, and we're trying to open to medical fraternity very soon, particularly the medical students. It's called Research and Entrepreneurship Development for You. So we have a couple of things. This is the Vita Kion, the video you have seen. So there are two boys, one PhD, another is a ready interns from IIT Guwahati. They together created this company. This is neurodrishti for the blind people. It can detects the object and gives you the sound signal to tell the blind person that, okay, this is that, this is that. And then this is a breath analyzer, for the diabetes. So without pricking, taking blood sample, you can tell that, okay, what is sugar. So these are the facilities we have. You have seen in the corporate video. So this is what I just mentioned in our MCC. So sorry, this is the HPS. We have it at our center in Okla. Like this seminar series, we also do a seminar series, Cobotalk, every second Wednesday. Last Wednesday, we have a very interesting professor from Georgia Tech talking about surgical wear, robotic guided wear. And I think with the NURAG, we should exchange our list of participants so that both can enjoy each other's seminar series. This is our drone technology park, at Sonipat, which is 50 kilometers from here. And this is the upskilling. I go a little fast without spending much time. This is international collaboration. Coming to my medical journey, as I said, 2019, Ashish Shuri, who had been long associated with some other professors, said, no, can we do something designed for the neurological? And that is the time one of my PhD students worked on flexible kind of this tool which can be controlled through tendon. So we give some idea. Later on, one of our other professor, Professor Sunil Jha, is collaborating with him, and now I think they are developing something, which would be going to the animal trials possibly. But before that, during my journey, we did all the analysis in finite element. We did some experiments and tried to correlate, basically understanding the physics of that kind of tool. Then this AI journey for me started with student Deepak Raina, who actually initiated this tele-ultrasound, what you have just seen. And for your information, robotics and AI is the intersection area where we'd like to work, and that's artificial intelligence robot. And here, as you all know as a doctor, so it's the concept of neuron comes into picture. To be very honest, I'm not so expert. I know some combination of these things are done to get some output. So what is the basic thing here is where physics is not known, like Newton's second law, we know if a body is pushed, it will go with certain acceleration. But where it is not known, like how I as a person will behave in given a situation, so you have to take lots of data and to do some kind of a curve fitting that's been done through this networking and to get some kind of behavior. And mathematically, this is basically optimizing some errors between the true values and the predicted values, to understand what is the kind of physics will be there for that system. These are mathematical jargon. Let us skip it because time is also an essence for us. And here is an example of how it is done. It's like upper arm and lower arm. And you give some input and you get some output. In this case, I know physics very well, but to demonstrate what AI will do, so AI actually will be giving this data to feed in to those kind of optimization of the functions, and it will give some output behavior, which I'm showing it here. For example, this blue is my original data, and the model output is this orange one. And so there is an error, but without knowing the physics, you can still get the behavior. That is the beauty of it. But then there are risks involved, the cost involved. because that kind of model would take very long time to get the behavior, because millions of data you have to be processed, for which you need a supercomputer. Supercomputer will generate heat, and heat means it will be pollution, the cost, no? So you have to do a balancing act between what is known, what is not known. So the best thing is people call it, no, physics based, AI, or physics supported AI. This is some kind of, correlation between the physics based model and the AI based model. It is 90% reduction in time is happening once the model is trained. So here is some simulated environment. The robot is taught how to write B, sorry, 3, E, and etc. Hello. And some skill set has been imparted to the robot here. Finally, Deepak, he started here, as I just mentioned, tele-ultrasound. Later on, he moved to Purdue because there's a Government of India program is there. A student can spend 2 years there. And he actually made this thing. So using phantoms, so finally his PhD defense, he has demonstrated you can have fully autonomous ultrasound. Once you put under this robot will be doing the scanning. It will understand the good quality and bad quality images that he has trained based on some experts' comments by radiologists, and finally implemented those algorithms. And now here, but before it gets commercialized, it's a long way to go because of other certification and other accuracy and stuff. Before I'm going to close it, couple of information and knowledge for those who are interested to be associated with the robotics. Like many other associations around the world, in India we also started the Robotics Society. So I would urge, I'm one of the active member in that society. You can become a member and probably contribute to the medical robotics, because that domain is fairly small at this moment. And then what I appeal to Anurag and the team is, instead of asking questions to the participants to judge whether they're listening to me properly or understanding things properly, maybe alternatively we can put forward this kind of team engagements where the participants, let's say there are 30 people today here, in the next 2-3 weeks period, we ask them to form teams, or rather we can form the teams and ask them to summarize that what is this lecture about and how can they take it forward. And then after 2-3 weeks, we can kind of ask other peers to grade them so that our time is saved. And finally, at the end, after 2 weeks maybe, the best team can be given some kind of a reward, and all successfully completed people will get the certificates. Out of 30, some may not be interested to take it to the completion. And I think the engagement, team spirit, networking, everything might be better. As I put forward, I've been doing it for the last 5 years in various forums. So this is my appeal if you want to take it forward for better engagement of MIC lecture series. So with this, I would conclude. So I explained robotics at IIT Delhi and in India. Some of the robotic contents need to be learned. IHFC, I explained that. MCC, I have showed videos. And very briefly, I spoke how the AI can be done. And before I show my thank you slide, I would like to make an appeal that all the researchers we do it, I have been noticing for the last 15-20 years very closely, we generally do not refer papers and publication from our own soil, means Indian soil. We are happy to refer many foreign things, but I think we need to encourage or rather acknowledge our own contribution. And to all my students, I have a strict instruction: unless 10% references from the Indian soil, I refuse to read it or sign any thesis, even as an examiner. And the second part is to be aware of what is happening around us. I must visit a laboratory or institute. So I would request if the doctors can visit the students, third year, fourth year, fifth year students can visit us. We would like to visit you and have more collaboration going on, because engineers and doctors should come together to develop products for the medical healthcare system. acknowledgement to all my fellow friends, students. And finally, this thank you slide for me, created by my colleague from Tezpur University using the Robo Analyzer software. My website is there, my email and my mobile is public. You can take a snapshot and reach out to me whenever you feel like. So thank you very much for the opportunity, Anurag, you have given to me. And now I am ready to take questions, comments.
Thank you, Professor. I think you gave a very good glimpse of what robotics is doing in various domains. And I'm sure, I'm sure many here are excited and stimulated to work on more of such ideas and projects. And a lot of the attendees are young medical students and students who I'm sure love to play with these toys, as they call it. But now you have shown that how it can be placed to impact for national building and agriculture and defense and even social service, as you've shown. Thank you for that. I think we are almost. I think we used up all the time, but I'll still ask one or two questions because I think where we are at this juncture, it's very interesting because typically, as I know, robotics was more about mechanics till now. But now with AI coming in, we foresee that AI, like robots, will be making decisions on their own. So, how do you, as a follower of a traditional robotics, you see this new era of AI-enabled robots who will be deciding on their own and will be independent?
Yeah, very good question, Anurag. And I think for the community, this is a question comes very often. Many people are scared. And so the question is, any new technology comes, we should be adopting it positively, carefully, by evaluating its merits and demerits. Okay. As I just mentioned in the last video which I was showing in, if you know the physics well and you don't care for the physics, no. In fact, I was listening to Professor Osama Khatib, came from Stanford Robotics Research Center in a conference at IIT Mandi, and the similar question was asked. He said, never overdo things. He's 80 plus. No? He said, never overdo it. Wherever physics is known very well and 100 years of research results are available, no, please use them. Do not try to use AI just to repeat the same thing. Wherever information is not available, knowledge is not available, please generate. So with this, I see a very kind of a positive developments for the world. Talking about India, India has a very good chance to lead this because we are already strong in IT and AI is just a top up on the cake.
Great. That is very promising and hopeful. Coming to medicine, what will be one thing which you will love to see being taught in medical curriculum, which you as AI or robotics person would like to see? What we should learn?
Yeah, I think introduction to robotics and AI in medical application, a simple program like we call it 1 credit or 2 credit course, which is about 14 hours or 28 hours. Introductory course can be given to all medical students as a first year. And if they are further interested, then it can be added with advanced level courses. And almost whatever I have talked today is a lecture 1 hour. This could be little bit in formal way can be put as a 1 credit course. Maybe some of the technological detailing of not simulation, the analysis part could be deleted, but bring more medical related examples. It could be good introductory course for all the medical, and this could be made possibly compulsory. If you're scared about the marks and everything, maybe it could be made compulsory but not graded.
And maybe my last question to you today, how do you see the future, like maybe 20 years from now? What would be life like?
Yeah, that's again very good question. Life would be lots of technologies, but that brings challenges as we have started seeing depression, restlessness, right? So for last 7-8 years, I'm trying to understand bit of spiritualism on the health and medical sciences. I would love to see if some of these spiritual practices can be brought in as a part and parcel of healthcare sectors, and more friendship with engineers and doctors. There could be a nice program which some universities are doing it, at least in IIT level. They call it technology with medical specialization. If the medical college, I know because of the bandwidth may not permit, but if they can synergize. So in short, bring technology with spiritual blend for the betterment of the humanity, actually, I would call it.
Yes, I think in any phase, balance is always the answer. So
Exactly.
balance of things.
Yeah.
So on that note, I think we'll end this session. Thank you,
Thank you.
Prof. Azad, a lot for showing us this word of robotics. And thank you everyone who attended live and on YouTube. Thank you very much.
Thank you very much. Yeah, and love to see some activities going on by the students, taking robotics as a toy or as a social, whatever we like it. Okay, thank you very much. Bye bye.
Thank you.
Okay.